All right, the check-in activity is a lot like what we're doing today, so I'm just going to work this out. And then this is our last day of practice before we review and test. So here we go. So what we already did was we already made on a previous check-in, what is that? We already made a free body diagram with the squirrel and its weight. And its normal force. We already did all that. That was negative 4.905, so that's positive 4.905. And the rat's pushing this way, and there's friction this way. This question tried to trick you. It asked, what's the mass of the squirrel? Mass is in kilograms. It already gave you the squirrel's kilograms. It said 0.5, and that's the answer. I had required it to say 0.5, but I changed it so it says you can just put 0.5 and it's fine. I did not think of that. Anyway, first question did. Good. So I recreated our free body diagram so we can add this info. If the force of friction resisting the squirrel's motion is 2 newtons to the left, okay, so the squirrel's motion is with the applied force, the way the rat is pushing it. We got the force of friction 2 newtons to the left. I wrote this question when there were squirrels and rats in the attic, and they're gone now, and that's good. I don't know if they just got bored or what. I don't think we did a whole lot to make them leave, but they're gone. So just in case you were worried about my attic. Anyway, we got the 2 newtons to the left, and the rat is pushing to the right with the force of 4. So I can put that on my free body diagram, force of 4. What's the acceleration of the squirrel? Asking for acceleration of the squirrel. We already know the mass of the squirrel. And we need to know the force. So it just gave us 2 forces. We got 2 newtons to the left and 4 newtons to the right. We need to figure out the net force and then use that to figure out the acceleration. So net force is, what's 4 minus 2? Okay. That force ends up being 2 to the rat. No puns. And let's work it out, I guess. I'll write my work where the answer says. I'm a rebel. Okay, we're doing F equals MA. F is 2. M is 0.5. Solve for A. I wanted to say equals A, so I got to make that 0.5 cancel. It says A times 0.5, so we'll divide both sides by 0.5. Oh, 2 divided by 0.5 is 4. That's acceleration, so it's meters per second squared, and we got the acceleration! Okay, so it now asks for what's the coefficient of friction between the squirrel and the ceiling joist? With the squirrels. So, coefficient of friction, as you can see here, as was included in the check-in, and it is included in your assignment today. When we do the review and test, I'm going to ask that you write these down somewhere and have them ready, and that way I don't have to have the formulas in a question for you all to find. Mu is the coefficient of friction, and FF is frictional force, and FN is normal force. So we're going to use this formula to figure out what mu is. It's asking for mu. If we're using that formula to figure out mu, we need force of friction and normal force. And it told us force of friction right here. Force of friction is 2 newtons. And normal force. Oh, that was way up there. We got that. That's 4.905. Right up here, where was it? Normal force? Right there, okay. And we just need to divide those. Force of friction divided by normal force, so 2 divided by 4.905 is some kind of number. Oh. You know what it is? That's, no. 2 divided by 4.905. 4.41. 0.41. I think I just said 0.4 in there. So we got the coefficient of friction. That's basically what this assignment is it asks you a series of questions about the same object. And then it goes to another object and you got to do the same questions or a slight variation on them. Does that seem all right? Okay. Try out friction 3, please.